Today we are going to discuss about the course MEV 003 Environmental Law and then Management. So today in that topic also, that is a management of air treatment technology. So we have experienced and also previous sessions we have discussed a lot more about air pollution as well as what are the air pollutants and then how they are emitting from the industries and then polluting the general environment as well as the human health. So air pollution, we know that as such represents one of the huge environmental risks to the global human health. So this pollution affects all regions irrespective of the caste, creed, everything, all types of settings and socio-economic groups and also all age groups. So it is used as a marker of sustainable development. So it is a very crucial topic to discuss about it. And also the most important sources of air pollution also produce the climate modifying pollutants, that is carbon dioxide. Normally we can call it as black carbon. So there are many concerns about air pollution which are reflected in the sustainable development goals. So by 2030 we have to reach these sustainable development goals. So air pollution levels in cities, which is cited as an indicator for the urban sustainable development, that is goal SDG 11, and also access to clean energy, particularly clean household fuels as well as the technologies, which is highlighted as an indicator for the sustainable energy, that deals with the sustainable development goal number 7. And also the mortality rate, which is due to the air pollution, maybe it is ambient as well as the household collectively, which is used as an indicator for the health, that is covering under the sustainable development goal 3. So before understanding the treatment technologies of air pollution, we have to understand that what is air quality. So whether we are able to understand air quality, are there any parameters to understand the air quality? So one such parameter is there, that is the air quality index. So the Environmental Protection Act that maintains a system of rating the safety of the air in a given area, particularly in any of the area, which is normally called it as the air quality index. So understanding the air quality index is so crucial because it gives every one of us the vital information about the conditions of the air in our location and how the quality of the air in our city that can impact our health on daily basis. So we can also understand which is a measure of how air pollution affects one's health within a short span of time. So the purpose of air quality index is mainly to help people to know how the local air quality impacts the health. So this AQI is needed to provide a metric for warning citizens, because they have to understand, they have to know the dangers of air pollution at various levels of intensity. So it is one of the primary causes of health ailments and also premature deaths in the entire globe. So the World Health Organization estimates the ambient outdoor air pollution that kills around 3 million people every year. Just you have to see the sad state of affairs. So the most common air pollutants normally we will see in outdoors are the criterion air pollutants normally, because EPA they have categorized these this type of air pollutants into criterion air pollutants, which we have already discussed in previous sessions. So these criterion air pollutants are ground level ozone, if you recollect it properly, particulate matter 2.5 we have discussed, as well as the particulate matter 10, and then lead, carbon monoxide, nitrogen dioxide and also sulfur dioxide. So first we have seen that ozone pollution. So because that is also one of the criterion pollutant. So ozone comes from the emission of the volatile organic compounds that interact with the sunlight and also the heat to form the ground level ozone, which is an important chemical in the photochemical smog. So the ozone pollution that can irritate normal eye, nose as well as the throat, and also the it will remain for the longer duration in the people's lungs. So particulate matter, and the next to the ozone, this particulate matter air pollution is mainly consists of the fine particular size, that is 2.5 microns in size, which are small enough to penetrate into the lungs as well as the bloodstream. That also we have discussed. And then this particulate matter pollution that can cause heart as well as the lung disorders and increase a person's chance of developing lung cancer. So, both sulfur dioxide as well as the nitrogen dioxide, which are emitted from the industrial areas as well as the automobiles. So, they can definitely cause the respiratory ailments like asthma, and also it is first thought to be a contributor to the asthma and also which is related to the emergency room services. So, high levels of exposure that can definitely reduce the lung function permanently. And the next to the particulate matter, the next one is the carbon monoxide, which is released into the air primarily by the incomplete combustion of fossil fuels, and it is colorless, odorless, and also we are unable to identify and then recognize the pollutant of the carbon monoxide. When inhaled in large amounts, it can easily leads to confusion first. It starts and then dizziness and also finally leads to death. So, the levels of atmospheric lead, which is decreased by around 98% since 1980, but lead as a pollutant is still be found in the atmosphere, as well as when exposure to this lead contaminant, it can cause a variety of problems. Especially, it can impact the kidney function and the entire nervous system and the immune system, and also the developmental problems in the children. So, due to this type of dangers of ambient air pollution, a system for warning us, especially the citizens, about abnormally high as well as the dangerous levels of ambient air pollution is highly required. So, the air quality index is one of that parameters to make us understand the levels of air pollution in the general environment. So, here we have to understand that how it works, the air quality index works. So, depending upon the level of atmospheric air pollutants which are present in the specific area, the ranking starts from good air quality to hazardous air quality. So, each ranking system has a corresponding number value, because they have given that number value as well as the color code, so that we can easily identify, easily understand that how the surrounding air will be is polluted. So, the first ranking in the air quality index that represents good air quality. So, it is represented by the color green and also contains the value 0 to 50. That means if AQI is, the value is between 0 to 50, we can understand that it is a good air quality in that particular range. So, air which is found in the good category normally poses a very little, or we can say that no risk for the health of the general population. And the second category of the AQI that contains the acceptable, we can say that, or otherwise moderate air quality, which is represented by the color yellow. It also contains the values from 51 to 100. That means the air is generally safe. We cannot say good, but it is safe. But those who are sensitive to the air pollution, they have to take some precautions, as they may experience sometimes respiratory symptoms. So, the third category of the AQI represents the air that is unhealthy for sensitive groups, and it is symbolized by the color orange, and the values are between 101 to 150. So, that means the general public is not likely to be negatively impacted by the air. Sensitive groups like older people and the children, which are at risk from the exposure to particles which are present in the air. And the next is, that is the fourth stage of air quality index, is symbolized by the color red. That means air that is highly unhealthy. So, it contains the values of 151 to 200. So, and at this level the air can start having adverse health impacts on the entire population. So people, those who are sensitive and also children, they can experience much more serious adverse health effects. In the next category, that is number 5, that is indicated by the color purple. So it contains the value of 201 to 300. So this ranking means that the air is very unhealthy and the entire population who can experience more severe health impacts. And the last, that is the final category of the AQI, is represented by the color maroon, and it contains the values 301 to 500 what we are experiencing nowadays. So air which is present in this range is categorized as hazardous, and at this level an emergency alert would usually be broadcast about the hazardous conditions. So the entire population is likely to be affected by the air quality, and immediate steps should be taken to protect oneself from the air, as it can quickly cause health problems. So at the very unhealthy and hazardous levels, we have to limit the spending time outdoors if possible, only going out when it is absolutely necessary. So stay away from the freeways as well as the major centers of traffic, and then go out when pollution levels are very, very low. So we can also use industrial grade face masks to limit the amount of pollution what we are breathing. So we will also want to invest in quality air filters and air purifiers for our home, and also the understanding the air quality index, which is critical for our health. So who is most at risk from this air pollution? So we have seen that people with lung diseases like asthma, and then chronic bronchitis, and also the children, including the teenagers. So active people of all ages who exercise or work intensively outdoors. So these people will definitely affected by this one. So some healthy people are also more sensitive to ozone type of pollution. So understanding the air quality index is important because it keeps us informed about how to protect our health. So now we will look into the air quality management. So air quality management, we know that means all the activities which are related to the regulator authority undertakes to help to protect the human health and also the environment from the harmful effects of the air pollution. So the process of managing air quality, that can be maybe understand as a cycle of 5 interrelated stages, or the elements we can call them as. Firstly, establish goals which are related to the air quality, and secondly, need to determine how much emission reductions are needed to achieve the goal. And air quality managers normally use emission inventories, and then air monitoring, air quality modeling, and other assessment tools to understand the air quality problem fully. Thirdly, developing control strategies, and air quality managers in this category, they will consider how pollution prevention and emission control techniques can be applied to achieve the reductions which are needed to achieve the goals. At the fourth level, need to implement programs for pollution control strategies. So the regulations or incentive programs which lower the emissions from the sources need to be put in place. So regulated industries need to train and assist in how to comply with these rules and how to execute. So all these rules needed to be enforced properly. So in the last level, it is important to understand and also undertake ongoing the evaluation to know if your air quality goals are being met or not. So this type of cycle is very dynamic process, and there is a continuous review and assessment of goals as well as strategies which are based on their effectiveness. So all parts of this process which are informed by the scientific research, which provides air quality managers with essential understanding of how pollutants are emitted, and then how these pollutants are, once it is emitted into the atmosphere, there are so many factors, wind speed as well as pressure, how they are transported and then transformed into the air and their effects on the human health and also the environment. So with all these, now we will discuss about some of the important controlling methods which you have studied in your topics. So the controlling methods for air pollutants basically classified into two categories, that is control on the basis of the source type, that is the stationary or the mobile phase, as well as the second is the control on the basis of the type of pollutants, whether it is suspended particulate matter, whether it is a gaseous pollutants, like this. So in the very first stage, that is a mobile source, that means we all know that is a moving sources like aeroplanes, trains and automobiles, whereas the stationary sources are concerned, they are fixed sources, that is the industrial sources. Maybe it may be a power plant or it may be a factory and other facilities like that. So stationary sources are again divided into major area sources. That means major sources, that means they will emit either 10 or more tons of single air pollutant or 25 or more tons of a combination of air pollutants. So because on the basis of the load of the pollutant, it has been divided. So the second is the area sources, that means they will emit less than 10 tons of a single pollutant or less than 25 tons of a mixture of pollutants, that is a combination of pollutants. So in high enough concentrations, the pollutants which are produced either by the mobile or from the stationary sources, they could cause adverse health effects to the atmosphere as well as the surrounding environment and also especially the human life by increasing the average global temperature and decreasing the atmospheric visibility, obviously we are experiencing, and diminishing the air quality and affecting the human health. If you will look into the industrial setup, there the air pollution control equipment as well as the systems which are used to regulate the emissions and also to how to eliminate the potentially hazardous substances, for example particulate matter and also volatile organic compounds and then gaseous substances which are produced by the manufacturing as well as the processing systems. So these control equipment that prevent the release of chemicals and vapors and also dust by filtering and then purifying the air within the working environment. If you will see, typically fans as well as the blowers which are present in the industry, so they will direct the industrial exhaust as well as the emissions into the air. Thereby the pollution control equipment should be there which remove or reduce the air pollutant load through the combustion. So that is in that process destroying the pollutants, and the next is the conversion, that is the chemically changing or we can modify the pollutant to a less harmful compound, and also the final stage, that is a collection, that is the removing the pollutant from the waste air before its release into the environment as well as the atmosphere. So with all these we can see that how many measures are the controlling measures are there for the stationary sources. So there may be emission rates that should be restricted to a permissible level for every single pollutant by each as well as every industry. That measure can be taken. And second is the continuous monitoring of the pollutants that can be done to know the emission levels, and also by using the green fuels and or otherwise fuels with low sulfur and ash content. And air pollution control equipments must be incorporated. We have to have a regular monitoring on that, and temporary shutdowns of the sources that can be done for a period of time when there is a danger of heavy accumulation of pollutants, and good operational practices of the equipment that may also play an important role in reducing the formation of the air pollutants. So some of the techniques that can be exercised are the first we can discuss about the cyclones. So these are also known as the dust collectors. These cyclones are air pollution control devices which are similar to the air filters that will separate dye particulate matter from the gaseous emissions. So usually in this technique, instead of employing filtration media, cyclones utilize centrifugal force to collect and they remove particulates or the particulate matter. So once these gas streams enter a cyclone, that is a contaminated one, they flow along a spiral path within the cylindrical chamber. So in that cylindrical chamber there is a swirling motion that forces large particulate matter against the chamber wall, which slows their inertia, that is a speed, and also causing them to drop into the collection hopper which is below, so that the further processing as well as the disposal will become easy. So once it is done, the cleaned gas streams will be released out of the cyclone system. So these cyclones are typically employed for the filtration purposes, especially the particulate matter which are maybe above or equal of 50 millimicrons in diameter. Some models are capable of greater than 90% efficiency for particulate matter which are greater or the equal of 10 to 20 microns also sometimes. So that means the efficiency will be depending on the size of the particulate matter. So usually additional filtration devices which are used to control air pollution like baghouses which are employed, which is followed by the cyclones in an air pollution control system to remove the residual smaller particles and collected from the gas stream by the cyclones. And next to that we can the other technology is also seen, that is the wet scrubbers. These are also known as wet adsorption scrubbers or wet collectors. Especially they will be using for the liquid solutions, typically water, to collect and remove water soluble gas as well as the particulate pollutants from the especially industrial emissions. So this wet scrubbing process either passes a gas stream through a liquid solution, or it may sometimes inject a liquid solution into a gas stream. So as the gas stream comes into contact with that liquid, the solution absorbs the pollutant, removing it from that stream. So the next to this wet collection chamber, another important technology is also used, that is the electrostatic the precipitators, ESPs. Just like air filters as well as the cyclones, these electrostatic precipitators are also one of the important air pollution controlling devices. They are used to collect and remove the particulate matter like dust from the industrial emissions and also the exhaust. So these ESPs especially transformers and to create high static electrical potential difference between the charging electrodes and the collecting plates. So once the gas stream passes between these two components, an electric charge is introduced to the particulate matter that attracts the particulate matter to the collecting plates. Similarly to the air filters, particulate matter accumulation is periodically removed from the collecting plates and deposited in a collection hopper which is present below that instrument, either through the mechanically disloading the particulate matter or by introducing water to clean off the particulate matter. So it is employed to the method which is known as the ESPs. They have multiple collection plates and their efficiencies normally exceed 99%. So next technique is the fabric filters. So these fabric filters, which are also known as the bag houses in general terms, they are a category of air filters. They typically employ the cylindrical fabric bags, if you will look into the picture, to trap and remove airborne dust and other particulate matter. So as air passes through a bag house, the particulate matter collects and accumulate on the filter's surface. So that means the gradual accumulation increases the efficiency of the filter, that allows smaller particles to collect and also causing a buildup of pressure across the filter fabric. So some bag houses are also capable of attaining almost 99.9% of efficiency even for small particulate matter. So these type of filters are which are suitable for the filtering out the air pollutants in a variety of industrial processes like power plants and metal processing centers and foundries, and also multi-stage cleaning systems as well. So the particulate accumulation and the resulting pressure, which is a differential, that is a prompt that need for the periodic cleaning. So there are several other methods are also employed by the bag houses, that is removing the accumulated particles from the filter bags, like shaking the filter bags and also introducing an air flow into the filter bags in the opposite direction, so that the filtration process will be more efficient. And also that is pulsing compressed air into the filter bags in the opposite direction to the filtration process. And many pollutants, both natural as well as synthetic, are gaseous in nature and also require specific as well as the specified technology to effectively remove the pollutant from the exhaust or the process gas stream. So some gaseous industrial pollutants like acid gases, that is a hydrochloric acid, sulfuric acid and hydrogen sulfide, and inorganic gases if that is the sulfur oxides, nitrogen oxides, ammonia, and also organic gases, ethanol, and many volatile organic compounds are the hazardous air pollutants. So some of these procedures are for this, especially these gaseous pollutants, are the absorption. So we know that absorption is a physical or the sometimes it is a chemical process of removing a pollutant from a gas phase media by dissolving the pollutant into a solvent media. So commonly the solvent media is a liquid phase, but it can be a dry bulk solid in certain systems. So the material that absorbs, normally call it as a solvent, and the gas that is to be absorbed is known as the solute. So the most common form of absorption is wet scrubbing. So wet scrubber is a generic name, normally we can give it to control that device that uses the process of absorption to separate the pollutant from a gas stream. And the next process is adsorption. Adsorption is the mass transfer process in which a porous solid that comes in contact with the liquid or the gaseous stream to selectively remove pollutant or the contaminants by depositing, that is a adsorption, them on that solid platform. So the contaminants that which are being removed are normally called them as adsorbate, and the solid which is doing this process is known as the adsorbent. So the adsorption process that can be both a physical as well as the chemical process. In physical adsorption, we will see that the adsorbate molecule, that is a contaminant, that adhere to the adsorbent materials in a physical bonding force which is known as the van der Waals forces. If you will see the chemical adsorption, a chemical bond is created between the adsorbate as well as the adsorbent. So this bond is known as the chemisorption. So chemisorption is normally occurs at the elevated temperatures when energy is required to break chemical bonds. And chemisorption is, of course, essentially the same process which is observed in the catalytic oxidation. So the most common adsorbents which are used in the industry are the activated carbon because high surface area, and silica gel, activated alumina, that is alumina oxide, and also the zeolite. And most important adsorbent selection, how can we select on the basis of the pore size as well as the distribution and also particle size and the chemical nature, surface area and surface polarity. Especially the polarity is most important characteristic features for selection because it determines the type of adsorbate for which any particulate adsorbent will have the best performance. So another one is activated carbon, which is most common non-polar adsorbent, and polar adsorbents that have the great attraction to absorb the moisture. So most of the industrial exhaust streams, they contain moisture. So the use of polar adsorbent is significantly limited for air pollution control system. And the next one is the condensation. That is a process normally used heavily throughout industry to convert a gas or vapor into liquid form. So, any gas can be reduced to a liquid by sufficiently lowering the temperature or increasing the pressure. This condensation process will be employed. Some examples we can see that is a distillation of various hydrocarbons in refining operations and drying of air. So, condensation can be used to remove a pollutant from a gaseous stream if the dew point of the pollutant is higher than the carrier gas. So, if this is true, the total gas stream that can be reduced in temperature to below the pollutant's dew point. So, that will then separate the pollutant from the remaining gas stream as a liquid. So, these are the things some we have to understand that when we have to use the condensation technique or not. Sometimes condensation that occurs because the pollutant molecules which are slowed as well as crowded so close, that is together, that the attractive forces between the molecules that can cause them to condense into the liquid. Normally this phenomenon is known as the van der Waals forces. So, next if we will see that the incineration process. The incineration of volatile organic compounds and hydrocarbon fumes usually done in the special type of incinerator known as the afterburner. So, to achieve the complete combustion, so the afterburner must provide the proper amount of the turbulence as well as the burning time. So, it also maintain a sufficiently high temperatures. So, sufficient turbulence or the mixing is a crucial, we can say that it is a key factor in combustion because it reduces the required burning time and also temperature. So, a process which is known as the direct flame incineration can be used when the water gas itself is a combustible mixture and also that is not required the addition of air or fuel. So, with all these technologies what we have studied, we have to understand the depends upon the size and depends upon the nature of the pollutant in the gaseous pollutant. So, with these I would like to conclude that so far we have discussed about various types of air pollution treatment technologies like combustion, which is applied when the pollutants are organic gases or the vapors, that is organic air pollutants which are exposed to flame or catalytic combustion when they are converted to less harmful products, that is a carbon dioxide, and they may produce the water. And the second technology we have seen as that is absorption. In this technique, the polluted air that containing the gaseous pollutant which is passed through a scrubber that carries a suitable liquid adsorbent, and it will absorb the harmful gaseous pollutants. And also we have seen some of the adsorption procedures. The gaseous pollutants which are adsorbed at the surface of the porous solid, and clean air passes through that means of these controlling particulate emissions. So, with this type of there are some other techniques also we have studied, that is the fabric filters, wet scrubbers, electrostatic precipitators. So, there are and also some of the technology which is based on the gravity. So, in this process the particulates settle down by the action of gravitational force. So, with all these I would like to conclude this session. Hope you must have understood. We will discuss some more pollutant factors in the other session. Thank you.